Hello, welcome to the lesson number 3 of our Airbus A320 air conditioning system, chapter 21. So last time we discussed about the pack components. So we identified the components which are in the Airbus A320 air conditioning system packs, and we discussed the functions of the components as well, and so we tracked the airflow which went through the packs, and we came up to here where it says to mixer unit. Today we are going to discuss about the mixer unit. So this is the basic diagram of the mixer unit. Even though there are two air conditioning packs, the aircraft will only have one mixer unit. So as the name implies, mixer unit, so which means it will mix airflows. So not only it will mix the pack airflows, it will also add air from different other sources to this particular unit as well. So before going through or before we dive deep, we'll just try to identify the components which we will come across when we discuss about the mixer unit. Okay, so first we'll identify the components, and like the previous lesson, then we'll discuss about each and every component and their functions, right? So here we have the FCV. Now you all know that what is FCV. FCV is the flow control valve. So this part from flow control valve pack 1, so from flow control valve 2 it goes to pack 2. So this part we discussed last time, and last time I told you that after the flow control valve, the airflow gets divided into two parts. One part will go through the packs, other part will go through other part belongs to the hot air system. So I told you that day that we'll discuss mix unit and hot air system together. So that's what we are trying to do today. So we will not discuss flow control valve and pack part. So we'll discuss the mixer unit and the hot air part today. So you can see that after pack 1 and pack 2 there are two arrows. So these two arrows are the output from the packs. So it is this arrow. So here it says to mixer unit, and what you see here is that same arrow. So here you will have a pressure bulkhead, here also the pressure bulkhead, and here you will have a check valve. I told you that the check valve will prevent airflow going to the pack direction when the pack is not in operation. Okay, so we'll forget about this part. We'll identify the components which we have to identify when we study about the mixer unit and the hot air system. Okay, so again today also we'll try to track with the airflow, but we'll try to get the basic idea about the components and their functions, right? So the airflow will come from the packs into the mixer unit. So we have two inlets to the mixer unit. Those two inlets are mainly from the packs, and you will see here there's another inlet. So mainly pack 1 will supply the mixer unit through a check valve which is located here on the pressure bulkhead. Pack 2 will supply the mixer unit through a check valve which is located on the pressure bulkhead here. And then you can see that here it says from cabin, and here you have some sort of a component, and here you have a fan sort of a thing, and here you have another arrow. So these two are the recirculation fans. So the aircraft has two recirculation fans which will operate whenever the aircraft is supplied with power. So whenever the ground power or the aircraft power is connected, these fans will operate continuously. And here what you see here is the filter. So this has two filters. So you have two recirculation fans and you have two filters. These are cylindrical type filters. So you will see these recirculation fans and the filters, and this is a check valve. So these parts you will see when you remove the aft partition wall in the forward cargo compartment. So then only you will have access to these components, right? So what happens here is that I told you the function of the mixer unit is to mix the airflows. I told you that it gets airflow from packs, and it also gets airflow from the cabin as well, and that air goes into the mixer unit through these filters. Air is drawn into the mixer unit by these fans, which are known as recirculation fans, and through the check valve. Again, why you have a check valve here is to prevent airflow from traveling towards the recirculation fan when you have pressure or when you have air in the mixer unit. So this check valve will only allow recirculation fans air to go into the mixer unit direction only, right? And here you have another inlet into the mixer unit. It says LP ground connection or emergency ram air inlet. So this is basically the low pressure ground cart connection. So we'll say now, if you don't have the APU running on ground and you need air conditioning system, what you can do is you can use a ground air cart, LP ground air cart or ground air conditioning cart, and you can connect that hose here. So the mixer unit will get supply from that external ground cart. So the cabin will have the required amount of conditioned air into the required zones. And the emergency ram air inlet, so this operates based on a logic. So and they share the basically there's another check valve after the emergency ram air inlet. So basically they share the same duct when close to the mixer unit, right? And we'll discuss about this emergency ram air inlet later. And here you will see a sort of a divider, and here you will see the same divider but with dashed lines. So here what is shown is that from here to somewhere here, the airflow will not be able to cross from this part to this part or this part to this part, but when it comes here, the airflow can mix. So basically the left side of the mixer unit is mainly supplied by the pack 1, the right side of the mixer unit is mainly supplied by the pack 2, and you can see that the LP ground connection and the emergency ram air inlet is also connected to the left hand side of the mixer unit. And when you go further up, you will see another sort of an duct arrangement here, and you will see that here it's also dashed, and this is basically a duct, and here you have a actuator, and you can see that it says mixer unit flap actuator. So this has a specific function as well. So if you just have a look at the image, you will see that, as I told you, it has dashed lines, which means it's a duct with holes which allows airflow to go into this part, and we'll discuss that also later. So first we'll have the we'll just have a look at the components. So you can see that the mixer unit has how many? 3 outlets, mainly 3 outlets, right? So those outlets leads to this outlet, this goes to the flight deck. So I told you that when it comes to air conditioning system, the 320, the supply to the cabin is based on 3 zones. Mainly you have 3 zones where you get air supplied into the cabin. One is the cockpit, other part is the forward cabin, the next part is the aft cabin. So for cockpit you have a separate duct from the mixer unit where you get conditioned air in. So here you can see that this duct leads to the flight deck or the cockpit, and you can see that here there's another duct. This duct will supply air to the aft zone, and here you will see there's another duct. This duct will supply conditioned air to the forward zone. And you can also see that there are temperature sensors in the zones as well as on the ducts. So if we just have a look at these temperature sensors, so number 5, number 4, and here number 4. So 5 is the flight deck temperature sensor, number 5 is the 4 is the zone temperature sensors. Here number 5 is the flight deck temperature sensor. Here is another zone temperature sensor. So this temperature sensor, flight deck temperature sensor, is located on the cockpit towards the rear CB panels, and this temperature sensor, the zonal temperature sensors, are located on the lavatory and galley extraction duct. Why it is located on the lavatory and galley extraction duct is so when it is located in the lavatory and galley extraction duct, it can be the temperature sensors can be ventilated via the lavatory and galley extraction system. Here the temperature sensor is ventilated by the avionic equipment cooling system, and here we have another 3 temperature sensors which is denoted by number 6. So that is the duct temperature sensors. So this plays a certain role when it comes to indication. So in case if a duct goes to, we'll say a duct temperature reaches the temperature of the air coming to the flight deck or the zones reaches a certain temperature, and this signal will be used to control the trim air valves or the trim air pressure regulation valve, which we will discuss later, right? So here you can see that there are another 2 temperature sensors. One is this is the cabin mixer unit temperature sensor. This is flight deck's mixer unit temperature sensor. So even though it is located here, this temperature sensor is used to mainly monitor the temperature of the air which will be going to the flight deck compartment, and this part will be used to monitor the temperature of the air which will flow to the forward zone or the aft zone, right? Basically those are the components which you will find on the mixer unit itself. And then we'll have a look at the hot air system, right? When it comes to hot air system, I told you that after the flow control valve, air get gets divided into two parts. One will go through the packs, other part goes through the hot air system. So this is where the airflow get divided, and from here we'll discuss the hot air system. So you have, after the flow control valve, part of air went to the pack and other part we took out as hot air. So that is why it is colored in red. So this is not temperature regulated yet, so that's why you see that in hot. And here also it comes through a check valve. Now you know the function of the check valve. It will only allow air to flow in only in one direction. That is the function of the check valve. So you can see that we have a tapping from pack 1 side, we have another tapping from pack 2 side, and these two will go through a specific valve here. So this is the trim air pressure regulating valve. Why you call it trim air pressure regulating valve? So you call it trim air because it is used to control hot air or the trim air and pressure regulation part. So the function of this valve is to ensure that the pressure of the hot air is maintained at a value of 4 psi above the cabin air pressure. So why you need to maintain trim air at a higher pressure than the cabin air is, now if you just track these lines, and you will see that this hot air will be introduced to these ducts through these valves. Now you will see that here you have a valve, so flight deck trim air valve, and here you have another valve, forward zone trim air valve and aft trim air valve. So through these valves the trim air will be introduced to each zone. So why you keep it at a higher pressure than the cabin pressure is, so you can see that the air will be introduced into this area, so that into the ducts. So these ducts, inside these ducts, so these ducts are connected to the cabin, so the pressure inside these ducts will be the same as what you find inside the cabin. So when it comes to pressure will travel from high pressure to low pressure. So to mix this hot air efficiently with this cabin air or the conditioned air which will flow into the cabin, you need to keep this pressure in the trim air line at a higher pressure. For an example, if we say now the cabin pressure is at we'll say now 10 psi, so the pressure of the hot air should be at somewhere around 14 psi, so it will efficiently mix to achieve the desired temperatures. So that's why we call this trim air pressure regulating valve. So it will control the trim air flow into the system, as well as it will control the pressure of the trim air which will be entering the system. So basically those are the components that you will find in the mixer unit. Next we'll discuss the functions of these components in the mixer unit and the hot air system. Okay, we'll discuss about the trim air pressure regulation valve first. So we are going to discuss about the trim air system components first. The first component is the trim air pressure regulation valve. So this trim air pressure regulation valve, I told you the function of the valve is to ensure that the hot air pressure is maintained 4 psi above the cabin pressure. So that is to ensure efficient mixing of the hot air with the cold air. And you will see, if you have a look on the valve, you will see that this has a solenoid and a switch. The trim air pressure regulation valve is a pneumatically operated electrically controlled valve. So this electrical control is achieved using the solenoid, and in the cockpit you have a push button which says hot air. So by using this push button you can energize or de-energize the solenoid to control the valve to open or close state. And you have to remember another thing, this is a pneumatically operated electrically controlled valve. So which means even though the valve is controlled to open using the solenoid by electrical power, you still need pneumatic pressure upstream of the valve to open it. So it will be kept on the closed position by a spring. When you have the required amount of pressure upstream of the valve, then only the valve will open and allow the hot air to flow into the system. So, and there's another thing about this trim air pressure regulating valve. If any duct, so you can see that here there are 3 ducts, one duct leading to flight deck, other duct leading to aft zone, and the other duct leading to forward zone, and you have temperature sensors here, and any of these temperature sensors will say it reaches a temperature of 88 degrees Celsius, right? So if any temperature sensor reaches 88 degrees Celsius, this trim air pressure regulating valve will be controlled to close, and you will get the fall light in the cockpit, and you can select it off, but automatically when the duct temperature reaches 88 degrees Celsius, the trim air pressure regulating valve will automatically close because of the position disagreement. The cockpit switch, it says it's at the auto position, which means it's open, and actually now the valve is closed because of this temperature issue. So you have a position disagreement. Because of that you get the fall light in the cockpit. So if any temperature sensor or any duct temperature sensor reaches 88 degrees Celsius, you get the fall light there, the valve will close, and you can reset it, you switch it off and switch it on, but the valve will only open if the temperature goes below 88 degrees or so. The valve will not open if the duct temperature is still above 88 degrees Celsius. So basically what will happen is, when the any duct temperature sensor reaches 88 degrees Celsius, the duct temperature sensor will send a signal to its related computer, and that signal, based on that signal, the air conditioning system control computer 1, so something which I forgot to tell you, the trim air pressure regulating valve is controlled by air conditioning system control computer 1. So any duct temperature sensor reaches 88 degrees Celsius, he will send a signal to its related computer, and the computers will talk with each other, and the air conditioning system control computer 1 will de-energize the solenoid of the trim air pressure regulation valve, thereby closing the valve. And the same manner, when you select the cockpit switch to off, the same signal will go to the air conditioning system control computer 1, and it will again de-energize the solenoid and the valve will close. And you can also see that the micro switch in the valve sends signal to both the computers. You can see that the signal from the switch goes to air conditioning system control computer 2, and the same signal goes to the system 1, and this is to basically detect the position of the valve, whether it's open or closed. And you can see that the control signal comes only from the air conditioning system control computer 1. So the solenoid gets the signal only from the air conditioning system control computer 1. So when we travel further down after the trim air pressure regulation valve, you will see a switch here. This is basically a hot air pressure switch, basically a pressure switch, and you can see that this also gives its signals to both the computers. So it signals air conditioning system controller 1 and 2 both. So what is done using this temperature signal is that, so if now we told you that the function of the trim air pressure regulating valve is to keep the pressure of the hot air 4 psi above the cabin pressure. In case due to failure of the valve, if the pressure increases above 6 psi, so that is the threshold which is set by the manufacturer, so that pressure can damage these hot air ducts. So to ensure that nothing will happen if the pressure increases above the threshold, the pressure switch, when it senses a pressure somewhere around 6 psi, will send a signal to both computers, thereby the computers will generate a ECAM fault in the cockpit. So the crew will know that there's a issue with this particular trim air pressure regulation valve, so they can action accordingly. And if the pressure drops to somewhere around 5 psi, the fault will disappear or the system will get normalized. So that is the function of this pressure switch. And next in the system we have the trim air valves. So I told you that there are 3 trim air valves. There can be the 4th valve if the optional cargo heating system is used, but here we are not going to discuss about the optional cargo heating system. So here we have the 3 valves which controls the hot air going into 3 zones. That is, here we have the flight deck trim air valve, here we have the forward zone trim air valve, and here we have the aft zone trim air valve. And these trim air valves are operated by a stepper motors which is integrated into the valve itself. And you can see that the flight deck trim air valve is controlled by air conditioning system control computer 1, and the forward and aft zone trim air valves are controlled by air conditioning system control computer 2. And there's another thing when it comes to the trim air valves. Whenever the trim air pressure regulating valve closes, so whenever the trim air pressure regulating valve closes, the trim air valves will close. That is an automatic feature. So when this closes, all the valves, all 3 valves of the trim air system will close. That means if trim air pressure regulating valve closes, flight deck trim air valve will close, forward zone trim air valve will close, and aft zone trim air valve will also close. So basically those are the main components you will find when you talk about the trim air system. So if we summarize, so we had airflow divided into 2 parts after the flow control valve. So one part went to the pack, other part came to the hot air system. The hot air from the pack flow control valve 1 and flow control valve 2 goes through this common valve, which is trim air pressure regulating valve, which is controlled by air conditioning system control computer 1 using a solenoid, and position of the valve is given to both the computers using a micro switch, and using the cockpit switch, or if any duct temperature reaches 88 degrees Celsius, the solenoid of the trim air pressure regulating valve will de-energized and the valve will close. And whenever the trim air pressure regulating valve is closed, these trim air valves will also close. The trim air valves are controlled using stepper motors. So the flight deck trim air valve is controlled by air conditioning system control computer 1. The forward zone and aft zone trim air valves are controlled by air conditioning system control computer 2. And the function of the trim air pressure regulation valve, main function is to ensure that the pressure of the hot air is maintained 4 psi above the cabin air to ensure proper mixing. And we also noticed that here there's a micro switch or the pressure switch. The function of the pressure switch is to give the ECAM warning if the pressure goes above 6 psi. Basically it's somewhere around 6.5 psi. So when the pressure in the duct after the trim air pressure regulation valve goes to somewhere around 6.5 psi, it will generate a ECAM warning, and when the pressure drops back to 5 psi, the system will get normalized, the warning will go off. Right. That is the summary of the hot air system. Okay, next we'll discuss about the components in the mixer unit itself. Okay, first about the mixer unit. So I told you that the function of the mixer unit is to mix air from different sources, and the mixer unit, I told you that you will find it located aft of the aft partition of the forward cowl compartment, and this is located below the cabin floor level. And according to the diagram that you can see that it has several air inlets into it. So it takes air from packs, it takes air from low pressure ground cart or the ram air inlet, and it also takes air from the recirculation system. So when we talk about the recirculation system, the quantity of the cabin air which will be mixed with the conditioned air will vary from 37% to 51%. So that is basically the mixing ratio of the cabin air to the pure air or the conditioned air which will be coming from the packs. And these recirculation fans, I told you, will continue to run when the aircraft is powered. So whenever you power up the aircraft, these recirculation fans will start and they will continue to run, and they will run at a constant speed. And you can see that there are filters. So these are replaceable filters. From time to time you have to replace these filters, and normally these are HEPA filters. So that is to ensure that unwanted material or viruses will not go into the mixture unit itself. So to prevent those unwanted stuff from entering the recirculation fan and the mixture unit, you have these filters. Next we have this mixture unit flap actuator. So you can see that the flap actuator controls sort of a flap which is located inside the mixer unit. I told you that this is also a duct which has openings in it, and now we'll have a look at this duct and try to understand the function of this special feature. You will find this only in Airbus A320 aircrafts. When it comes to A330 aircrafts, even though the systems are similar, you will not find a duct like this in the A330 mixer unit. Okay, so the function of the mixer unit flap is to ensure that sufficient flight deck air supply is maintained even the pack 1 is selected off or faulty. So in simple terms, if you have a look at the diagram, I told you that left side is dedicated to mainly flight deck. So in case the and you can also see that the left side gets its supply mainly from pack 1. In case if this pack 1 is faulty or pack 1 is selected off, and you will not have continuous fresh airflow into the flight deck. So conditioned air can still come from pack 2, but the air will have to come here, and it can't jump from right hand side to left hand side in this region. So it has to travel this way, up, and through this part only the air can come to this side. So when it comes to cockpit, it's a critical area, so you have to ensure that proper ventilation and air conditioning is maintained in the flight deck. To ensure that, they have installed this specially designed duct. So what will happen is, in case if pack 1 is selected off or faulty, in other words it's not working, you don't have supply from pack 1 to into this part, the pack 2 air will come into the mixer unit and it will enter this duct, and when this flap is open, the pack 2 air will supply the flight deck duct. And what you have to understand is that whenever the pack 1 is selected off or faulty, air conditioning system control computer 2 will automatically open this flap via this motor. So now we'll say, now you don't have supply from pack 1 to the mixer unit. Air conditioning system controller 2 will know that pack 1 is not working, so he will open this flap here. We have pack 2 working, so air comes from pack 2, comes here and enters the duct. Because the flap is open, the air will enter the flight deck duct, and you will have conditioned air or the cold air and proper ventilation into the flight deck using pack 2 air. And next on the mixer unit, we have 2 temperature sensors. So the function of these temperature sensors is to give the actual temperature of the mixer unit to its related computers. So the left hand side temperature sensor, you can see that it's connected to the, so this is basically connected to the air conditioning system control computer 1. So the left hand side temperature sensor is connected to the air conditioning system control computer 1, which means this temperature sensor will send its temperature signal to the air conditioning system control 1, and the temperature sensor which is located on the right hand side of the mixer unit will send its signal to the air conditioning system control computer 2, right? And so each temperature sensor has 2 thermistors, and one thermistor is connected to the lane 1 of the air conditioning system control computer. The other thermistor is connected to the lane 2 of the related air conditioning system control computer. And next we have duct temperature sensors, which are indicated by number 6. So the function of the duct temperature sensors is to detect temperatures in the ducts. So you can see that there are 3 duct temperature sensors. You have a temperature sensor for forward zone, for aft zone, and you have another sensor for flight deck. And so these temperature sensors will detect the duct overheat condition. I told you that if any duct temperature goes to somewhere around 88 degrees Celsius, that temperature sensor will send a signal to its related computer, and this particular signal, based on this signal, the air conditioning system control computer 1 will close the trim air pressure regulation valve, and at the same time, because trim air pressure regulation valve is closing, all the trim air valves will also close. And next we have these zone temperature sensors, and so I told you that you have 3 zone temperature sensors, 1 for cockpit and 2 for cabin, and each of these temperature sensors have 2 thermistors, and these 2 thermistors, one thermistor will send the temperature signal to the air conditioning system control computer 1, and the other will send the signal to the air conditioning system control computer 2. So, and if you have a look at the diagram, and you will see that you have 2 computers here, and these 2 computers will control their own sensors and valves accordingly. And you can see that air conditioning system control computer 2 is the computer which is only connected to the CFDIU, or the central fault display interface unit. So if there are any faults detected by the air conditioning system control computer 1, he will send that signal to air conditioning system control computer 2, and the computer 2 will transmit that signal to the CFDIU. So I told you in the first lesson that flow calculation part is done by air conditioning system control computer 1, and the connection with the CFDIU in the air conditioning system is only with the air conditioning system control computer 2, and these 2 computers crosstalk with each other, and they share the information among the computers. So basically this is the mixer unit and the hot air system of the Airbus A320 air conditioning system. So now we'll have a look at the operation of the emergency ram air inlet flap. So as you can see here, this is a simplified diagram. This will be used to explain the operation of the emergency ram air inlet flap. So we'll just try to identify the components. That you can see here that there's a ram air push button. You will find this in the cockpit, and you will see this button, this push button, ditching push button, that is also in the cockpit. And for the time being, just forget about this logic and just focus on this part. And here you can see the emergency ram air inlet flap. This is located on the left hand side of the fuselage, and I told you that the LP ground connection and the ram air emergency flap duct share the same duct. So you can see that here there's a flap sort of a thing. So if the ground cart is supplying, the flap will close the ram air inlet side, and the supply from the ground cart will go through the check valve into the mix unit. And if the ram air inlet is supplying, so it will close off this part, and it will supply to the system, and this connection will only be available when the aircraft is on ground. You can't use this part when the aircraft is in flight. So here we have the mixer unit, and you can see that the it's like that previous diagram. You can see the connections from the mixer unit to the zone, and additionally you can see the outflow valve here, and you can also see the packs here. So now this I told you that the operation of the emergency ram air inlet flap has a logic incorporated. So we'll try to understand how the emergency ram air inlet works. Okay, so why you need the emergency ram air inlet is, in case if you have both air conditioning packs failed in flight, so you will not have anything to supply the mixer unit, and therefore you will not have air supply to the zones. It can be a flight deck or the forward cabin or the aft cabin. You will not have air supply if you don't have the packs. So in this situation you need to have some sort of a air supply source to this these zones, otherwise you will not have fresh air for passengers to breathe in. So in this case, by opening this emergency ram air inlet, you can take outside air directly to the mixer unit, and from there you can distribute that air to the related zones. And this is not the only time which we will use the emergency ram air inlet. So the emergency ram air inlet will also be used in case if you have smoke during the flight. For the removal of smoke, you can open this emergency ram air inlet and allow the fresh air to come in to remove smoke from the cabin via the outflow valves. So you will have outside air coming here through the scope, going through the check valve to the mixer unit, and the fresh air will enter these zones, and the air will be taken out through this outflow valve to outside the it will be sent out through the outflow valve. So to emergency ram air inlet to operate, I told you that there's a logic. So what will happen is, when you select the ram air push button, so you have to understand that you have to press this manually. So when you press the emergency ram air inlet push button, okay, right, when you press it on, and if the ditching push button is selected off, right, the signal will go to the emergency ram air inlet flap to open. So you have to press the emergency ram air inlet push button in the cockpit. At the same time, you have to ensure that ditching push button is selected off, or otherwise it's not selected on. If this is selected on, even though you press the ram air push button, the emergency ram air inlet flap will not open. And if this is selected off or not active, and this is pushed, emergency ram air inlet is pushed, the signal will go to the emergency ram air inlet flap, and the flap will open. Even though the flap opens, the outside air will not enter to mixer unit. Why? Here you have a one-way valve. Now the aircraft itself has a certain amount of pressure in the cabin. So now outside, so this is from the basic. Outside, the pressure of the air will be at a lower value than the inside of the cabin. So if air from outside to enter into the cabin, the air pressure inside the cabin should be less than the pressure outside the aircraft. So this check valve will be kept close at the close position until these two pressures are equalized or cabin pressure goes below the outside pressure. So to ensure that outside air can come in, the aircraft will have to descend to an altitude below 10,000 feet. So even though you press this push button, emergency ram inlet emergency ram air push button, and even though this is not selected, ditching is not selected, even though the ram inlet flap is open, the air will not be able to come into the mixer unit or the cabin unless the pressure inside the aircraft cabin or this mixer unit is less than the air pressure outside. Okay, so and when the aircraft comes below 10,000 feet, and if this differential pressure is less than 1 psi, and at the same time if your outflow valve or the mode selector switch in the cockpit, that is the outflow valve mode selector switch is in the auto position, if the differential pressure is less than 1 psi, the outflow valve will automatically open 50%. Then the pressures, the air pressure inside the cabin will reduce, allowing outside air to come in. So if we summarize, we can use the emergency ram inlet flap in case of you have both pack failures or for smoke removal. How to do this? You switch on the ram air push button. At the same time, you have to ensure that the ditching push button is selected off and ram air push button is selected on and ditching is selected off. The emergency ram air inlet flap will open, but the airflow, the outside air will not flow into the cabin unless the differential pressure between the outside and the inside is less than 1 psi. So to get it to 1 psi, what will happen is, if your outflow valve mode selector switch is in the auto position, when the differential pressure is somewhere around 1 psi or less than 1 psi, the outflow valve will be controlled to open, therefore allowing the outside air to come into the cabin. So you will have fresh air from outside come into the cabin to compensate for lost packs or to ensure smoke is removed from the cabin. That is the function of the, so basically that is the function of the emergency ram air system. Next, in the next lesson or in the next video, we'll summarize this part. So we learned about the pack component, the basic layout, the pack components, and we learned about the mixer unit and the hot air system. So in the next lesson we'll summarize all these lessons, and so if you have already followed lesson 1 and lesson 2 and this lesson, so when it comes to summary, you will be able to understand the concepts and the functions very easily, and I'm sure that you will have a better picture of the air conditioning system of the A320 aircraft. So until next time, stay safe, fly safe.